we have a 50 gram mass sitting on some rotating disk or some rotating object that's going through 5 revolutions per second initially, and after some interval 2 revolutions per second. We want to find its kinetic energy at 5 revolutions per second and at 2 revolutions per second if it's at 20 centimeters from the axis of rotation. Okay, so 20 centimeters from the axis, rotation rate 5 revolutions per second. What does that mean? Well, a revolution means you go around the circle once. Now, we're trying to figure out the kinetic energy of this mass. We need to know how fast it's going. So, how fast is something going if it goes 5 times around a circle of 20 centimeter radius every second? Well, what question do you need to answer to determine this? We're going to go 5 times around the circle. 1, 2, 3, 4, 5. Going to do that every second. How far does it go in a second? Well, you've got a circular path of radius 20 centimeters. It's got a circumference. If you've got a radius of 20 centimeters, what we're doing here is we can find the circumference, we can find the area, we can find the arc distance for any central angle. Okay? So I say we can find any of these things. And which one of these is going to be relevant to determining how far this thing travels in a second? Well, the circumference is how far it goes around the arc. And that's how far it travels. Every time it goes through a revolution, it travels a distance on the arc equal to the circumference, not to the area, not to an arc distance for some other central angle, although that can be relevant as well. Okay, so 1 revolution corresponds to a distance equal to the circumference. 5 revolutions corresponds to the distance equal to 5 times the circumference. So, omega naught is 5 revolutions per second. That implies that the mass goes around the circle 5 times every second. So, how fast is it moving? It's moving 5 times the circumference per second. And the circumference, of course, is pi times the diameter. Now, we had to digress. Even though we talked about it in the preceding class, people still don't seem to understand the relationship between circumference and diameter. Okay, pi is defined to be the ratio of circumference to diameter. Pi is circumference divided by diameter, so circumference is pi times the diameter. Okay, so we have 5 times pi times the diameter per second, and the diameter is 2 times the radius. So we have 5 times 2 pi r per second. Now, I would have pulled out that 2 pi r quantity for the circumference right away if I thought people were in general aware of this. But mysteriously, people don't seem to be aware of how you find a circumference or the area of a circle, and are still predictably confusing the two. Okay. We need to get over that. We need to understand that pi r squared is the area, and that has units of centimeters squared or length squared. Circumference is 2 pi r. Why? Because circumference over diameter is pi, definition of pi. So circumference is pi times the diameter, which is pi times 2r, which we write as 2 pi r. We simply have to know these things. Okay. We can't have to stop and think about them. They have to be right there. Otherwise, we lose track of what we really need to think about. Now, 5 times 2 pi r per second. In this case, r is 20 centimeters. And 2 pi r, you can figure it out, is 126 centimeters. So that's 126 centimeters is the circumference of a 20 centimeter circle. Now, when I asked what the circumference was, some people said 120. Okay, and that was a pretty good answer because it's about 6 times the radius around the circle. So that gives you a good ballpark figure. And we see that the 2 pi r, more accurate figure, And this is still an approximation. 126 is an approximation. And we could, 125.6. There are lots of ways to approximate this, but to the nearest whole number, it's 126 centimeters when we do 2 pi r. And that compares favorably with 120 centimeters we get approximating pi by 6. Okay, well, that's then 5 times 126 centimeters every second, which is 630 centimeters per second. So what's the kinetic energy? Well, the initial kinetic energy, which I denote by KE0, is what? 1/2 mass times velocity squared. Now that we know how fast it's moving, in other words, it's real easy to calculate the kinetic energy. Velocity being 630 centimeters per second, we square that, and that gives us about 400,000 centimeters squared per second squared, and multiplying that by 25, which is half of 50, we get 10 million. So we get 10 million grams centimeters squared per second squared. Now, gram centimeter squared per second squared is an erg, that is a unit of energy. It's not our SI unit, but it's closely related to it. And 10 million ergs is 1 joule. And we could also get the 1 joule by making that 50 kilograms, or 50 grams, 0.05 kilograms, and this 6.3 meters per second. And if we work that out, we also get 1 joule. So 10 million ergs is a joule. If we express these quantities in kilograms and meters per second, our units will come out kilogram meter squared per second squared, or joules. Okay, well, now the final angular velocity is 2 radians per second. If we follow all this reasoning, we determine that the final kinetic energy is 0.16 joules. We can also determine that because 2 is 2/5 of 5, or 4/5 of 5. And our velocity is therefore going to be 4/5 as great, or 2/5 is great, or 0.4 is great. And if you square 0.4, you get 0.16 when you're squaring the velocity. You're going to square a number that's 4/10 as much. You're going to get 0.16 times the velocity, still the same mass. So you're going to get 0.16 times the energy. So you should be able to run through all this reasoning for the final angular velocity. And you should also understand the proportionality that if we have 4/10 of the velocity with the same mass, we're going to have 0.4 squared, or 0.16 times the kinetic energy. Now there's an alternate way of figuring out the velocity of the mass as it goes around the circle. 5 revolutions per second. A revolution is 2 pi radians. So 5 revolutions per second is 5 times 2 pi radians per second, or 10 pi radians per second. So we know our angular velocity is 10 pi radians per second. At 10 pi radians per second, what's the velocity at r equals 20 centimeters? Well, the velocity, if we know what a radian is, remember that a radian is the angle so that the arc distance on that angle is equal to the radius. So that 10 pi radians would correspond to a distance of 10 pi times the 20 centimeters. So 10 pi radians per second means on the arc, that's 10 pi times the radius per second, which is 10 pi times 20 centimeters per second, or 200 pi centimeters per second. If we calculate the kinetic energy on that basis using the 200 pi centimeters per second, same calculation we did here, except we got the velocity instead of 630 centimeters per second squared, we got 200 pi centimeters per second, and quantity squared. If we work that out, we get the same thing pretty much that we got before. It's right at 1, it's very close to 1 joule.